In today's video, we are going to be talking about function notation. Function notation is really important. You are going to be using it in Algebra 1, and then you will use it through all of Algebra 2 and beyond. So it is very important that you understand how to use this notation today. And as you have questions, I want you to pause the video and ask those questions because this stuff is really important. So I want you to think about a function like a function machine. Oops, hit the wrong thing. So if I'm thinking about a function machine, right? Here's my machine. You know about functions really well. And I'm going to tell you why you already know about them really well. A function machine works the same exact way as a vending machine, right? When you go to a vending machine, what happens? You put money into the machine, you tell it where to go, and then food comes out, right? That's all a function is. You put something in and something else comes out, just like a vending machine. If I was going to the vending machine for chips, I would put my money in the machine, I would tell it the location of the chips that I wanted, and then the chips would come out of the machine. That's all that is happening here. See this function right here, f of x? That's how you say that. So when you see this, it's not fx. We read that as f of x. So think of the parentheses as the word of. So what we're saying is this function, f of x, this is just like a nickname for y. So when we use f of x, we're just saying, hey, that equation y that you're finding, that is a function. So this lets you know when you're reading something that you have a function. It passes the vertical line test. That's what this notation right here is for. So in my function machine, we have f of x equals 3x. So let's look at our inputs. Your inputs are your x values. If I start with the input of -2, so -2 is going to go into my machine. -2 is an x value. So I'll have f of -2 equals 3 times -2. Let's look at what just happened. We said that x was -2, and so I replaced each of my x's with -2. So that means every time you see an x in f of x, replace that x with -2. This side right here is just notation. There's nothing to solve on this side. We're just saying, hey, we're looking at the function f. We're at the vending machine at the end of the hallway. This is telling you the location. And then inside, that's telling you what x is. So think about it this way. This is telling you how much what you want costs. So this is the location. This is the price, right? All we have to do is simplify over here using the order of operations. You could also use your calculator. What's 3 times -2? -6. So when -2 goes into the machine, -6 comes out. Let's try that again for a different one. Now we're going to try when x is 0. So when x is 0, it goes into the machine. So every time I see an x in f of x, I'm going to replace it with 0. Nothing to do over here. This is just telling us the notation. Hey, you're looking at the function f and you're replacing x with 0. Over here, we're going to do 3 times 0, which is 0. So when you plug 0 into the machine, 0 comes out. Let's see what happens when we plug 5 into the machine. So every time I see an x in f of x, I'm going to replace it with a 5. 3 times 5 is 15. So When 5 goes into the machine, 15 comes out. So that's what we're doing when we're evaluating functions. So let's practice that again down here without looking at the function machine. If it helps you, go ahead and draw your own function machine and you can plug it in that way. So it says to evaluate a function for a particular input, substitute the input value for x to determine the resulting output value f of x. So if I look at example 1, we have f of x equals 2x minus 3, and we want to evaluate that for f of 3. This right here is telling us, okay, x is 3. So that means that every time I see an x in f of x, I'm going to replace that with 3. So instead of f of x, I'm going to replace all those x's with 3. Because again, this 3 inside the parentheses tells me that x is 3. So every time I see an x in f of x, I'm replacing that x with 3. There is nothing to do over here. This is just notation. This is saying, hey, we're looking at the function f, and we're plugging in 3 for x. Over here, all you have to do with the order of operations. You can use your calculator to help you do that. Positive 2 times 3 is positive 6. 6 minus 3 is 3. So our answer is 3. Let's try that again for example 2. On example 2, we have g of x equals negative x minus 9 for g of 11. The 11 inside the parentheses tells us that x equals 11. So every time I see an x in g of x, I'm going to replace that x with an 11. This side over here is just notation. We're saying, hey, we're looking at the function g of x, and we're replacing x with 11. Over on the right side of the equation, I can't talk today. Negative 11 is just negative 11. Negative 11 minus 9 is negative 20. So my answer is negative 20. Let's look at example 3. Here I have h of x equals x plus 1 for h of 2. So the 2 inside the parentheses tells me that x is 2. So that means every time I see an x in h of x, I'm going to replace that with 2. Well, 2 plus 1 is 3. So my answer is 3.